This is the Digital Factory Podcast. I'm John Bruner. Today we'll be talking with one of the leading independent authorities on 3D printing. He'll tell us about where the real value is in additive manufacturing and how the industry is aligning itself to offer new technologies and products that'll meet that value. But first, you probably remember that back in May we held the Digital Factory Conference in Boston, and I'm pleased to let you know that the videos from that conference are now available for free at thedigitalfactory.com. Hear from leaders at companies like FedEx, GE, and Ford Motor who are transforming their operations with digital manufacturing. Just visit thedigitalfactory.com. The Digital Factory podcast is brought to you by Formlabs, which makes powerful, versatile, accessible 3D printers that scale from desktop to production. For more on Formlabs, visit formlabs.com. My guest today is Terry Wohlers. He's the authoritative analyst on 3D printing with a really broad view of how the industry works and where it's headed. Terry, it's great to have you on the program. Thanks so much for joining.
Oh, you're welcome.
So today we're going to be talking a lot about scaling 3D printing. This is kind of the hot thing in 3D printing today, is how 3D printing is going to move from prototyping applications into manufacturing, how it can support new kinds of products and new ways of making things. So Terry, I wonder if you could just kind of look back over the time that you've been covering 3D printing and tell us a little bit about how the scale of additive manufacturing has changed in the last couple of decades.
Sure, be happy to, John. So if you look back at the last couple or even 3 decades that 3D printing and additive manufacturing have been available, it's really been for relatively small quantities of parts with a wide mix of machines to support mostly design validation, modeling, prototyping, some forms of tooling, but mostly those other activities. And so you really don't need to have a lot of consistency or repeatability among your parts because these are very temporary models and parts that are being produced. Scaling it into production is a whole nother animal, and it really is, the manufacturing quality requirements are different. And it just is very challenging for some companies to get there, because now we're talking about really the same kinds of standards that were established for CNC milling, for plastic injection molding, and a host of other manufacturing processes. And some of the machines and materials are approaching the qualities that are expected, while many and arguably most are not. And it's not only it's not only the responsibility of the machine and material producers, but also their users, whole ecosystem to support that application. And we're evolving. We're getting there. We're beginning to see companies adopt it, where you can walk into a room and see it filled with machines manufacturing parts. But that's really the exception. The rule is more of a wide mix of machines used to support relatively low quantities of parts.
When you talk with companies that are interested in introducing some kind of production additive step, is the big obstacle design or cultural, or is it the cost of 3D printing? Have we gotten to the point where additive is actually cost effective enough to be introduced in a lot of places, but it can't be because of design barriers or process barriers?
Yeah, well, companies that are beginning to head down that journey, they uncover new ways that they can apply it, but at the same time, they're better understanding the costs and challenges that they must encounter. And design for additive manufacturing is one of them. It's a very big one, and it's a cost that sometimes they underestimate. They may first get into it not even knowing that it's important, and then they understand, well, to really make this cost effective, they need to rethink their designs. For example, it may not be a cost effective to do a part the same way they've molded it, for example.
Mm-hmm.
But if they consolidate two parts or many parts into one or fewer parts, then suddenly it can make sense to do it. But to make that determination, it requires some design talent and some experimentation to actually go through an exercise and to try it. And it's a bit of a chicken and egg thing. It's, well, they don't have the knowledge, skills, or even tools to do it, but they have to do it in order to know whether it's going to make economic sense to build a business case around the idea of using additive for production. So I think it's perhaps the single biggest obstacle to the broader adoption of the technology is that very fact of design, the lack of knowledge, skills, and mature tools to make it happen.
So how difficult is design for additive these days? Is it its own discipline, or is it something that's pretty easy to sort of fold into the capabilities of a typical mechanical designer or industrial designer?
Well, the starting point is to have an individual that is up to speed with modern CAD tools, that is open to new ways of thinking, is willing to try some new software that's being developed, some of which is, I don't want to be too critical about the software tools. Some are actually getting quite good, but if you look at maturity, they still aren't compared to, say, CAD solid modeling today, it's not anything close to it. And I'm referring to tools such as topology optimization, which is software that optimizes the strength to weight ratio to use the minimal amount of material to reduce material and weight. And those tools are better, but we're seeing improvements all the time, and that's a sign that they're still on a fairly steep curve in terms of development. And then likewise, the use of those tools. People are just now becoming used to the idea of using them, and then the interaction or the perhaps lack of integration between that software and your CAD tools. Often you have to export one and recreate, and then export and then import, and it's not a fully integrated system. Now, some of the major companies are working on that integration, and it's becoming better, but there's still a lot of work to be done.
I think your comment a second ago pointed to something very important, which is that design for additive manufacturing isn't just kind of a DFM step toward the end of a design process. It's really a strategic step at the beginning, right, where you identify places where you could use part consolidation, or areas where your old manufacturing process has imposed some kind of constraint on the shape or the function of a part, and now you can correct that. So it's really something you start thinking about at the very top of the process.
Yeah, and it really is a process. It's a journey. It's in the past you look at rules and guidelines for design for additive manufacturing. It's been at best a few individuals within the company. It's been based on tribal knowledge, and if you know Joe or Linda down the hall, you might gain some insight, but otherwise you're on your own, and it's trial and error. So companies are beginning to, at least companies that are moving more aggressively towards the use of AM for production. Those companies are documenting and putting together sets of guidelines and rules that then they can share and build upon among the groups within the companies. Otherwise, it's just a whole lot of trial and error. And I'm talking about things like, what's the smallest radius you can build in, say, powder bed fusion and clear the powder. And of course, it's not only the diameter, but it's also the length of the hole. And is it curved? And things like, what's the, living hinges? How are they built? And just a long list of, overhangs without the need for support material. And of course, it really depends. It's not universal. Those answers are they differ depending upon the material and the process, especially if we're talking about metals versus polymers, and even within those classes of materials, they differ. So it's very important for companies to to learn them and to document these design rules.
In terms of the progress that 3D printing has made in the last, let's say, 5 years, we love to follow the progress in the technology. I think it's natural to sort of look at how the machines are evolving, how the processes are evolving, what the features of the new machines that companies announce are. But what you're describing is a lot of kind of process research and applications research. If you think about where the real progress is happening now, is it more on the kind of technology development or on the application development?
Well, we're seeing both, but I would say in recent 2 or 3 years, it's been more on the application development. In fact, if you talk with people like Fried Van Crane, who's the founder and CEO of Materialize, he will say that most of the investment now that he's seen is on the application side and much less on the technology. Now we're still seeing lots of really interesting investment and development around materials and new machines and especially support equipment, not necessarily the machines themselves, but it includes them, but also for post-processing. But the point that Fried makes is that now the next frontier and maybe opportunity is to take these tools and some of this know-how and really put it to work in terms of applications. A case in point would be Align Technology. Invisalign is the company that, or is the brand rather. And if you look at that company, they're using technology that was developed back in the late 80s and early 90s. Of course, also newer technology too, but I'm saying the fundamental stereolithography technology they're using was, invented back then and hasn't changed dramatically, since then. But everything around it, the special application of producing these dental aligners to straighten teeth, that's where the investment has been. And I think the same is true for footwear, for eyewear, for automotive parts. The list goes on. That's where I think big investments will be made, is to develop these applications for these specific parts and families of parts for these different industrial sectors.
Is there a specific application that you have in mind that to you is the signal that you're waiting for this application to reach the market, and when that happens, you'll know that additive manufacturing has taken off at a really large scale way?
No, not really. I think much of what we need is in place. I believe the biggest obstacle to growth in a big way is, and when I say growth, I'm talking about instead of companies buying tens of machines, hundreds or thousands of machines that are spread across tens of sites worldwide, and that supply chain to develop to support these large OEMs. For that to happen, it really comes down largely to cost. The cost of a single part is generally much higher than the cost of a part made traditionally. Now, I have to be careful when saying that because it depends on the quantity. And that's really what I'm referring to. When you get up into the high quantities, the cost for traditional manufacturing per unit is typically lower. But there's this break-even crossover point where if you're producing parts up to, let's say, 50,000 units, if it's a relatively small part, then it can be actually less expensive to produce it additively than to produce a mold or whatever tooling and other manufacturing operations are required to produce it traditionally. And that break-even point, moving from if it's 50,000 to 100,000 to something much greater than that, will continue to change as the materials, the machines, and the support of that setup. As I'm talking about labor and other elements that are a part of it. As those costs are driven down, that break-even point will be driven to the right, meaning much higher. And that's where we're at. That's where I think the breakthrough will be, is when those costs decline to the point where we can now get into the more significant volumes of parts.
Yeah, that's John Dolcinos from Jabil Circuit has been on this podcast and spoke at the Digital Factory Conference a couple of years ago and pointed to break-even points between additive and injection molding that he's experienced at Jabil of between 10 and 20,000 units. And that's purely on a cost basis, comparing the cost of tooling to the incremental cost of 3D printing. And it seems like the break-even point would be even higher if you account for things like, the cost of sending some of your engineers to China, or the kind of development time cost of cycling through molds that take 6 weeks to fabricate, and so on. Once you kind of incorporate those, plus the strategic value of being able to change a design on the fly, that pushes the break-even point even further to the right.
Yeah, I know, John, and we've had a lot of interesting exchange, and I think we're in sync on that issue, and certainly in agreement. I don't, I would challenge the thought that it depends on where those machines are sitting, if they're in China or in the U.S. I think, with the exception of maybe the cost of power and maybe some other costs that, if you can automate or streamline the post-processing and also the upstream, what happens before you send the jobs to the build, if you can streamline those operations, I would challenge, or I would argue that, the U.S. or any country can be as competitive as any other country on the planet. With the possible exception of, like I said, if power or some other service is much less expensive in that region of the world.
So you see this becoming fully distributed then. There are a couple interesting lines of thought that I've encountered here, and I'm not sure that I have a preference for either, but in one line of thought, it's kind of what you're describing, that anyone can put a 3D printer in any country and operate it. And the difference, in cost structure just comes down to the cost of electricity and labor and real estate and so on. The other approach to this is 3D printing might actually concentrate expertise because it's so easy to do it anywhere. The cost of sending a file to a 3D printer somewhere else in the world is very low, and so countries will rapidly develop expertise. And if you're, in, let's say, Pakistan, and you need a part printed, you're not necessarily going to have to order it from a Pakistani 3D printing house. You can send the file to Singapore and have it made there and then shipped by air back to Pakistan. So the system could wind up favoring countries that have that are kind of first movers and that have excellent logistics networks over countries that kind of jump in and create localized services. Do you have a thought on which of those is the approach or the reality you think we're going to see?
Well, in reality, I think we'll see all of the above. It's a lot of trial and error, and people are sorting this out, and they're in various phases in developing this, in different regions of the world, or even within companies. Large corporations, they may have adopted it, but the actual penetration within that company may only be 5 or 10%. I mean, the opportunity could be much greater than what we're seeing. I think once you develop the process, once the design is frozen and you've automated the post-processing through the use of robots and other mechanisms, then I don't think it really is going to matter where those systems sit. I think they'll be sitting closer to the customers. I think in the future, what will really matter from a competitive standpoint will be design, and then the ability to really drive cost out of post-processing, because that's where the manual labor can come in, where if you have to have an army of people hand processing parts, removing support material, hand polishing, painting, and so forth, if all that's done manually, then that's going to drive the cost up to the point where it may not even be, it will not in some cases be economical to do it by additive manufacturing.
I'd love to go back to the to some questions about additive strategy. If you're a company thinking about introducing a product that depends on additive manufacturing, or you're thinking about beginning to implement 3D printing in production, what's usually your starting point when you talk with a company like that in terms of helping them think about their strategy for additive?
We first look at the types of products they produce, and if they are candidates for additive manufacturing. And let me give you an example. If you're doing stadium seats for stadiums out of I'm not even sure if they're blow molded or injection molded, but probably some plastic processing goes on to build the plastic seats. That's probably not a good candidate for manufacturing. But on the other hand, if you're producing lower quantities and smaller parts, and especially ones that have or could be more complex, in other words, maybe if it's a 20-part assembly, each individual part is simple, but if you could do through part consolidation, add complexity digitally, so then you could then print those, then it could begin to make sense. And the same is true with metal parts as well. You look at it, and does it make sense? And so then to go through that process, and in fact, we're working with a client company now, and that's it's not one that would be obvious. In fact, on the surface, like, no, this doesn't make sense. It really doesn't. But when you start drilling down a little more deeply, it's like, well, maybe by some redesign and the quantities and some other things. And this company's looking out not 5 years, but as many as 25 or 50 years. They're looking way out. So who knows what will happen by then. But so yeah, I guess to answer your question, John, is really to look at the products and the design behind them, and then of course quantity and size enter into that as well.
Speaking of metal 3D printing, I think we talk a little bit more about polymer printing on this podcast. I'd be curious to hear about your perspective on where metal is going. It's still, of course, a very expensive and pretty exotic set of processes that require a lot of thought and a lot of investment. We see a lot of applications in aerospace and medical devices. What are you seeing in terms of metal additive sort of moving down the value chain? Where is it going to head next after it's conquered aerospace and medical devices?
Yeah, so aerospace and the medical device industries have been the low-hanging fruit for metal AM, and that's where they've gotten their start. We've seen a lot of investment. Even so, the market penetration, we believe, is still relatively low. There's literally thousands of these medical and aerospace companies out there. And so there's still a lot of opportunity. I think the next frontier is automotive. Mm-hmm. And so if you look at the likes of GE Additive and HP, but even before them, X1, Höganäs, Digital Metal, mm-hmm. All four of those companies, and now Desktop Metal as well, the five companies have in common is that they are pioneering a new way of making metal parts. Now, X1 would argue it's not new because they've been doing this since the 1990s, and mm-hmm. Digital Metal not quite as long, but still quite a long time. And so the idea is to use inkjet printing to deposit binder onto metal powder and to process parts that way instead of using an energy source to melt. Basically, use very, very fine welding to mm-hmm. produce, which can be very effective, and that's what has been used largely to date. But this new way, this binder jetting could really be game changing in the cost structure or the cost of an individual part. I believe the jury's still out. I haven't seen. I've seen few companies that have embraced this for production, except for very, very small. The size of your fingernail or smaller.
Right.
Though that scale of part, most automotive parts and others are bigger. So, but if companies such as GE and HP are betting their hopes on this, and maybe in some ways even betting the farm to some degree on this, then maybe they're determined and they have the financial resources to make it happen. So I'm excited about it. Like I say, it's still where most of us are in a wait and see period to know whether or not it's going to work as they hope it will.
In the automotive industry and in general, I suppose, how much do you see the growth of additive having to do with customization versus with better kind of process efficiency or more efficient designs?
Well, I think it's the latter. That's where the big business will be. Now, I think producing custom products, custom parts that make your product more personalized, I think that will play into it, and it will help set you apart maybe from your competition, at least temporarily. BMW now offers that on their Mini Cooper brand. So yeah, I think at least in the short term, it could help some. But I think in the long term, in terms of where the money is spent, it's your mainstream parts that go into automobiles. The chassis parts, the drivetrain, in terms of metal, and then for the interior parts, principally for the polymer parts, but not just those parts. There's others too. The lenses that for the headlights, tail lights. There's just a long list of candidate parts that could be made by additive manufacturing, but it really comes down to cost. Not only cost, because there are some real high technical requirements in terms of the materials having to withstand the rigors of extreme temperatures, snow, ice, salt, sun, all those things that automobiles must encounter. Oh, not to mention the regulatory hurdles too that are required of automobiles.
If you were to think out 30 years, think about what a car might look like. How much of it do you think could be 3D printed versus conventionally manufactured? Yeah,
it's interesting you should bring that up, John, because we're seeing two dynamics going on. We're seeing the likes of Ford, Daimler trucks, BMW, and many others work toward building parts by additive manufacturing. And then at the other end of the spectrum, we're seeing startup companies like Local Motors, Divergent 3D. There was a company, a startup up in Winnipeg, Canada, called Irby, the Irby car that was built by additive manufacturing. So one way to approach the problem is sort of from the ground up. Let's start with a clean slate, and how could we design a chassis and body integrated, for example, and suspension and other parts from the ground up, and not be shackled by the past or by this is the way we've always done it, and this is our part list. How can we change those current parts, but rather how can we design from the ground up? And those two will probably grow together at some point. I guess they, to some degree, already are starting to meet in the middle. But if we look years ahead, I think a relatively high percentage of parts will be produced additively for automobiles. And the reason I believe that is that as time goes on, the materials will decline in price, and the machines will become so much faster and more economical. And through design, by part consolidation and weight reduction and performance increases as well, that could be a big one in the future. With those things combined, it will be difficult to compete with those that don't use these advanced ways of thinking to produce automobiles. To the point where you may not be able to compete. But that's a ways out. It's not 2025, I don't believe. But is it 2040? I don't know.
You make an interesting point about clean sheet designs, because I think we're about to get to this point between electric cars and then in an even bigger way with driverless cars, where it's not necessary to hold on to a lot of the design conventions that cars have had for a long time. In the case of electric cars, kind of the way that the hood is organized, the constraints that come with delivering power to all the wheels, the constraints that come with delivering and carrying fuel. In the case of driverless cars, even more dramatically, you no longer need all of the seats to face forward out the front window. You no longer need the controls. So I think we're going to see a lot of clean sheet designs, maybe not in the next 5 years again, but I totally agree. That'll be an interesting opportunity to think about the way that cars are made as well as the way that they're designed.
Yeah, I couldn't agree more. In fact, we're seeing, not only the existing OEMs, but also startup companies in California and Europe and elsewhere that are new, and they're able to start from scratch. And so a lot of new product development and using these new ways of thinking and AM machines to help support it.
So Terry, I ask every guest on the podcast a single question, which is, what is your favorite tool?
Wow, I have so many, just an endless number of tools around the home, the office, you name it. But I would say one, maybe two come to mind. I'll give you one and then tell you another that may be if you were to ask me in a year or two from now, I would name it. So I use a software called Evernote, and I don't know if you know it, but I use it for so much, for to-do lists, travel packing lists, client companies, home and personal items, lawn care, lists of contractors, insurance companies, who's my doctor, or healthcare stuff. You name it, you can use it, and so I like it a lot. And it synchronizes. It's a cloud-based app, synchronizes to all your devices, and it's just I can't imagine life without it. And so, but I know people who don't use it, and
right.
It doesn't. There's probably some Evernote competitors. I'd be surprised if there aren't, but it's just such a handy tool. Last week when I was in Germany, I was reminded how useful WhatsApp is. It's especially useful when you're traveling outside the U.S. because you can call anybody in the world virtually for free. And it's handy to have a wireless signal, but you can even use your data plan on your cellular phone to make a call anywhere. And it's just so powerful, not only for phone calls, but for messaging and sending information back and forth. And so I'm still relatively new to using WhatsApp. I think the younger generation here in the U.S. have been using it for maybe some time. Maybe a bit older generation outside the U.S. it's quite popular, but generally it's less popular in the U.S. than elsewhere. But it's a great little phone app, and so I would say those two, but currently Evernote takes first place.
The ability to call over data has really improved in the last few years. I remember just 6 or 7 years ago, it was pretty difficult to do what you're describing, where you get on a data connection somewhere in Europe and make a phone call or receive a phone call to your own phone number. It's amazing how far that's come and how much more seamless travel has become as a result. Yeah,
with all due respect to Skype, and we still use it from time to time, but when you're traveling, WhatsApp, for me, is just seamless. It's just so easy, and it works reliably. So that's become my go-to for communications when traveling.
All right, Terry Wohlers, it's such a pleasure to speak with you. If listeners want to find you online and take a look at the work you're doing, where should they look?
Well, the fastest would be to go to our website, WohlersAssociates.com. Most people misspell it, which is fine. If you just Google Wohlers and even misspell it, we occupy first of the most 2 or 3 pages on Google. So
that's a significant accomplishment.
Well, I don't know, but people tend to find us, and I've never had so much fun in this industry, and we try to communicate some of that at our website.
Terry, this has been a great chat. Thank you so much for coming on.
Oh, you're welcome, John. It's a pleasure.
Terry Wohlers was a speaker at the Digital Factory conference in May. You can find a video of his panel at thedigitalfactory.com, along with every other panel and presentation from the conference. The Digital Factory podcast is brought to you by Formlabs, which makes the Form 3 and Form 3L SLA printers and the Fuse 1 SLS 3D printer. You can learn more about those products and the full line of materials that go from prototype to production at formlabs.com. With the Digital Factory podcast, I'm John Brunner.